It's sometimes important to find the voltage within a specific component in that circuit. All right? When that is the case, and those components are all in series, you can use what's called the voltage divider equation in order to figure out what the what the voltage is inside a specific component. All right? With voltage division, you can think of it as being the total voltage is being supplied to the resistors or that area of the circuit times the resistor for which you want to find the voltage drop across, divided by the summation of all those resistors that are in series. So in other words, let's take a look at this. So if I have this circuit here where I have this resistor, and let's make it simple. All right, and this is being supplied by a voltage source that's, let's say, 10 volts. Okay, and I happen to know that this resistor is equal to, let's not make something easy. Let's make 5, and this one is 2. So this is 2 ohms, and this one is 5 ohms here. If I want to figure out what the voltage is that's seen across here, I want to figure out what the voltage is that's seen across there. One of you guys that I know should know this. Let me rephrase that. No, it's a say. Not because I don't think you know, but I don't want you to feel bad if you don't. That's right. Okay. What? No, I have to be. I understand. Okay, so if we want to find the voltage across that 2 ohm resistor, what it's saying that we can do is this. The voltage that's being supplied to the 2 of them in the series is equal to 10 volts. All right, so I'm looking for the voltage that's being dropped across this resistor. Let's call this one R1, and let's call this one here R2. So we're looking for the voltage being dropped across resistor number 2 here. I take the voltage that's being supplied here, which is our total voltage, and I'm going to multiply that by the resistor that I want to find the voltage across. So that is resistor number 2 in this case, divided by the sum of the 2 resistors. Okay, divided by the sum of the 2 resistors. So the sum of these 2 resistors would be R1 plus R2. Okay, and that will give us the voltage that's being dropped across resistor number 2. Okay? So this turns out to be equal to what? Since we're looking for this, this is 2 over 7 times the 10 volts, and that's equal to our VR2. And so our result will be equal to what? 10 divided by 20, divided by 7, whatever that turns out to be. I'm sorry? 2.85. 2.85, good enough. Okay? That's equal to the 2.85. 6. Or 86, okay. Round up 6. All right, now, if it happens that the components, these 2 components have the exact same value, then what happens is this. If you happen to see something like this on the exam, the components have the exact same value. Those 2 resistors have, let's say, if they were both 5 ohms, half of that voltage would be dropped across one resistor, the other half would be dropped across the third one, apart the third one. You know why I said that? Because I'm thinking about 3 voltage, what I'm going to say next. They were going to be dropped across the second one there. If you happen to have 3 resistors that are in series, and you want to find the voltage that's dropped across one of them, and they all happen to have the same resistor value, then the voltage that's being supplied here is going to be evenly distributed, dissipated across, or not dissipated, but dropped across each of them. So if it's 3 of them, and they all have the exact same number, okay? If they all have the exact same number, who cares what the number is? You just take that voltage source and divide it by 3, and that'll give you the value. Okay, so if it happens that, in fact, let me go ahead and erase this. If you guys are getting that from or before I erase, I just want to make a point so that you can quickly see this on the exam if it comes up. And there are a lot of questions on the exam where you're looking at circuit just simple circuits that they want you to calculate this stuff for relatively quickly. I'll leave it there for you. Okay. So let's say this is 5 ohms. That means you're gonna have 5 volts dropped here, 5 volts dropped here. If I change this to 6 ohms and 6 ohms, it'll still be 5 volts dropped here, 5 volts dropped here. No matter what it is, as long as it's the same, you will get the same. You get half of the voltage being dropped across one, half being dropped across the other. If it's 3 of them, the exact same 3 values, same thing. It's going to be 1/3 is going to be dropped across one resistor, 1/3 across the other, 1/3 across the third. Okay? If you see a question like that, that's one you can knock out in no time. You don't have to do a lot of thinking. You can devote more of your time towards something else that may be a little bit more complicated. Okay? Any questions about the voltage division type equation? Any questions?